All right, everybody. So this week, what we're going to do is we're going to continue talking about confidence intervals. If you look in the classroom, I have the tabs for this week's lectures. If you click on it, all my lectures this week kind of just go into a little bit of the theory that this confidence intervals for proportions are talked about, and then I do a bunch of lectures with your graphing calculator here. So, just like last week where we relied heavily on the graphing calculator to construct the confidence intervals, that's going to be the same this week. And then also this week, you have your next quiz that I posted. Okay, so this is going to be due by next Monday. Let me just open it up for a little bit. All it is just confidence intervals stuff. So stuff from we learned from last week when we talked about confidence intervals for means, and then stuff we talk about today. Just a reminder, if you could mute your mic. So I muted everybody just for the background noise. If you can unmute yourself if you have a question, okay? I highly encourage you to not wait until Monday night to complete the quiz, just while everything's still fresh in your mind. And just a note, when you use the graphing calculator this week to construct the confidence intervals, just let me know that you used it and write something like I have highlighted here when you use it, okay? All right, so before I get into the examples for today, does anybody have any questions about the quiz at all? You can post to the chat or unmute yourself if you do have any questions.
Can you hear me?
Yeah, I can hear you.
I don't know what happened with the screen, but it says safe driving mode. I don't know why is that.
Everybody else, could you let me know in the chat if you can see my screen fine?
Yeah, I can see the screen.
Yeah,
okay. I'm gonna leave and I'm gonna join back in then.
Yeah, that might be it.
Okay.
Yeah. Okay. All right. Well, let's go through two examples this week about these confidence intervals, okay? So here's the first one. In a recent survey of 1,200 adults in New Jersey, okay, so I just picked my home state up. Now, I just made this problem up, okay, so don't think this is real data, okay? It was found that 840 approved, not arrowed, of the governor's response to the coronavirus. Okay, so just imagine there was this poll that came out and they just asked people, do you approve or disapprove of how the governor of New Jersey is handling the coronavirus? Okay, so what we see here is this is the number of people who approve, and 1,200 is the total N for the sample. Okay, so the first question says, find a point estimate for the proportion of adults in New Jersey who approve of the governor's response to the coronavirus. So all a point estimate is the single value estimate, okay? So this is that p hat, okay, that we've learned about before. And so the p hat is just the number of people who approve divided by the total. So if we take our trusty graphing calculator and take the 840 people who approve of the governor's handling divided by 1,200, all right, we're seeing that it's roughly 0.7 or 70%. Okay, so just to kind of understand what's going on, so from this survey, we say 70% approve. Okay, but then this is the whole point of confidence intervals, all right? Do you think exactly 70% of people in New Jersey approve of how the governor is handling this?
No.
Yeah, it's not. It's not exactly 70. It's probably pretty close to 70, but what could the possible values be? What could the possible real proportion be? So this is why we need these confidence intervals. So the next question says, construct and interpret a 95% confidence interval for the proportion of adults in New Jersey who approve of the governor's response to the coronavirus. All right, if you have your trusty calculator, okay, take this out. We're going to use it now. Now, to do confidence intervals, if you remember from last week, you're always going to press the stat button. So I'm going to press stat. And I'm going to scroll over until I see tests. Okay. And what we want to scroll down to, all right, if you remember last week, we used this T interval option last week. So this week, you're going to scroll down a little bit further. And you want to find this thing called 1-prop z int. Okay, so I'll even write that here. 1-prop z int. Always, always, always for these proportions. Okay, you're always going to use that. All right, so under 1-prop z int, I'm just going to hit enter. And the good news is this is incredibly easy to use with your graphing calculator. All right, it just says, well, what is your X? Well, that's the number of people in the survey who approved. So that's 840 people in New Jersey. You're going to hit enter. N is your sample size. All right, so that was the 1,200 adults. You're going to hit enter there. Okay. C dash level, that's your confidence level. And just like last week, it's always defaulted to 0.95. So this problem asks for a 95% confidence interval. So I'm just going to hit enter here. I'm going to go down to calculate and hit enter. And how many people, if you could let me know in the chat, if you did this, followed along, see the same results I get. Got it?
Yeah.
Okay. All right. What you're seeing up here, this part right here, that's your confidence interval. Okay. So let me just put that here. So the first part of the parentheses, this 0.674, I'm just going to go to 3 decimal places, is the lower bound of the confidence interval. And this 0.726, when I round it, is the upper bound of the confidence interval. Okay. So all we did there was we just constructed it. All right. So now when you go to interpret it, okay, what this confidence interval means is I would interpret it this way. Based on this sample, we are 95% confident that the proportion of adults in New Jersey, my great home state, who approve of the governor's response to the coronavirus is it's somewhere between this 0.674, so it could be as low as 67.4%, and 0.726, so it could be actually as high as 72.6%. And that's it. It could be any value in between there. So using this calculator, was it pretty straightforward to get these confidence intervals?
Very easy.
Super easy, super easy. So when you watch the videos in the classroom this week, what I do is I show you how to do it by hand. It's worth just to watch it to see where these formulas come from. But then when you go to find the answer, you can just use the calculator. So when you go to do your quiz, this is really important. You need to tell me this. You need to just put something like what option you used. You need to tell me that I used this 1-prop z int. So when you go to turn in your quiz, make sure you write that on your paper somewhere. Okay? Any questions about this one? Okay. All right. I just want to do one more quick one and kind of talk about an interpretation of this. Okay. And this is something that I want people to be aware of when they see surveys, and what you can actually conclude and what you can't conclude from it using these confidence intervals. All right. Okay. So let's take a look at this example. So you have this politician. And a politician believes that more than 50% of individuals, okay, so when something more than 50% would be like a majority of individuals in his district, support a new policy, okay? So imagine this policy is, this is something that's kind of important to me, so I just put it in here. The policy is removing the cap on SALT cap deduction from your income taxes. So, if you pay attention to the tax laws, you can only deduct up to $10,000 on your income taxes of your state and local taxes, okay? And it really disproportionately hurts people in the Northeast. Anyways, so he wants to know, this politician, he wants to know if a majority of people, okay, more than 50% support removing this SALT deduction, okay? So to test this, what he does is he samples 50 people and finds that 260 support the removing this policy or removing this cap, okay? So the first thing we want to do is we want to find a point estimate for the proportion of individuals in his district that support this new policy. All right, well, all that is that's just your p hat, okay? So you take the 260 people who support removing the policy or removing the cap, excuse me, support the policy, divide it by the 500 people, and we see that it's 0.52. Okay, so what this is saying is 52% of people support this policy. Okay, is that 52% greater than 50%? I mean, obviously, right? Yeah, okay. So you have to be careful, okay, in how you use statistics, okay? So remember, this is just from a sample of 500 people. So when you see a survey like this that says, oh, 52% support this policy, what could the real possible values actually be? Because this is just from one sample. So let's take this result and let's construct a 95% confidence interval for the proportion of individuals in his district who supports this new policy, okay? So I'm gonna go back and I'm gonna use, one second. I'm gonna use the same, this 1- prop z int, okay, in my calculator. So I'm gonna press on my graphing calculator, I'm gonna press the stat button. I'm gonna go over to tests. And you have to scroll down a little bit. And it's this 1- prop z int. You always want this one for these confidence intervals for proportions. So I'm going to press enter. Now, when you do these problems, everything that's saved in there is from the previous problem, so I just have to change it. There were 260 who supported the policy out of the 500 people we talked to. We're going to leave the confidence interval at 0.95, and we're going to hit calculate. And what you're going to see is this is our confidence interval, okay? So it could be, the real value could be anywhere from 0.476 all the way to 0.564 when I round it, okay? So if it helps to see this as a percentage, you can change it there. All right, so remember, he wants to say that for sure, or he believes that more than 50% of the people in the district support this policy. So what we're saying here is, look, well, great that you got 52% on your survey result, but what we're really saying is, look, we're 95% sure that the real value of everybody in your district could be between 47.6%, as low as that, or as high as 56.4%. So what do you guys think? Does this interval support his claim that more than 50% of 50% of individuals in his district support this policy? What do you think? I got one yes, I got one no. Well, let me ask you this. Could the real value based on my confidence interval be less than 50%, looking at the confidence interval? Yeah, it sure could. It could be as low as 47.6%, okay? It could be that low. So even though he believes that more than 50% of individuals support his policy, when you look at the confidence interval goes less than 50%. So it could be that it's not. It could be that it's not. So you have to be careful when you see these surveys that say something like, oh, 52% of people support this policy. Well, what could the real values possibly be? Okay, you know, that's why these confidence intervals are important. So confidence interval here does not support the claim that more than 50% support the policy. Whenever you see these confidence or these surveys in the news, it's really important not to just say, oh, it's 52%. Okay, because, well, that's just from one survey of 500 people. So it's important to dig in and look at the confidence intervals and look at the margin of error. All right, class, those are the two examples. So here's the thing. Danny, it could be greater than 50%. Sure, it could be as high as 56.4%. Absolutely. But it could also be as low as 47.6%. So there's no way to say for sure that it's greater than 50% of people. There's just no way to know for sure because it can be any of those values in there. So if you want to find the margin of error of this poll, for the margin of error, you would use the 52%. Yeah, so if you wanted to find the margin of error of the poll, what you would do is you would take the high part of the interval, the 0.564, and you subtract your point estimate, 0.52. And what we're saying is the margin of error of this poll is 0.044. That's how you find the margin of error. That's a good question because you might have a quiz question like that, maybe. You do. Did that answer your question? Okay, good. You're welcome. All right, class, so that's really all I had for you today. Does anybody have any other final questions before I end the, glad it all makes sense. Anybody has any final questions before I end the recording and send this to you guys? All right, if not, just a reminder, okay, just a reminder. Make sure you get this quiz in, this quiz 4 by next Monday, okay? Make sure you get that quiz 4 in by next Monday.